3.4, solving exponentials and log equations. What we're going to learn: how to solve simple exponential and log equations, how to solve more complicated exponential equations, how to solve complicated log equations, and how to use them in real life problems. Here's a general idea how we're going to solve it. When you want to solve exponentials, if you get the bases a match, then you just solve the exponents. Same with logs. If you get them to be the exact same log, you just solve what's inside the log. Then we'll get to the fancier ones where you have to get rid of a log or an exponential in a second. Let's look at this one first. Like here, easiest way to solve this, if you could write these as the same base. It's like 32 is 2 to the 5th. If I write that as 2 to the 5th, this is 2 to the x, and then we're done. X equals 5. The next one here, I have log base 4 of x minus log base 4 of 8. That's a minus. I'm going to add this over. And it's not the only way to do this, but it's the simplest. These cancel. You get log base 4 of x equals log base 4 of 8. And now, these logs, you can just solve x equals 8. What you're technically supposed to do is take the base of both sides. And once you do that, these cancel, and you get x equals 8. Same thing over here. If you just move this over, we get natural log of x equals natural log of 3, x equals 3. Technically, you're supposed to take the e to both sides, and that would cancel out these natural logs, and x equals 3, but like that. Over here, easiest way to do this is you get the same base. 9, I could write that as a 3 squared. That has a 3, but it's on the wrong side. What if we flip it? Remember, the way you flip is you make it a negative power. So this is the same thing as saying 3 to the negative 1 to the x. If you just look at the powers, that's negative x equals 2, also known as x equals negative 2, divided by negative 1. Here we go. E to the x equals 7. But there's no way to solve it. You can't get the same base here. What we can do, anytime we have an e to the x, the way you cancel out an e is you take the natural log of both sides. We're going to take the natural log of both sides. So it's going to look like this. Natural log of ex equals natural log of 7. Then on this side here, I would like to move the x to the front. You have x natural log of e equals natural log of 7. Natural log and e cancel out, you just get 1. You just get x equals natural log of 7. Now that was me doing it the long way, showing you all the proper steps. Likewise, if you have a natural log, how do I solve this? You gotta take the e of both sides. It's a little funky, it's e to the power of both sides. So it looks like this. E natural log of x, e to the power natural log of x equals e to the power of negative 3. E and natural log cancel out, and you just get x equals e to the negative 3. Log base 10 of x equals negative 1. A couple ways to do this, you can rewrite it, but the general way to solve it when you have only one log, like over here they have 2 logs and they match, you just cancel them. You have a natural log on both sides, you just cancel them. The proper way of doing this is you take the base to both sides. So whatever this base is, you take that to both sides. I'm going to rewrite it so you can see what it looks like that. It's 10 to the power of log base 10 of x equals 10 to the negative 1. Anytime these match, they cancel, you just get x equals 10 to the negative 1, also known as 1 over 10. Over here, same idea, log base 3 of x equals 4. Since there's only one log, we're just going to take the base of both sides, 3 to the power of this and 3 to the power of this. I'm not going to rewrite it because I think we get the gist now. These will cancel. You just get x equals 3 to the 4th, or 81. Strategy for solving log equations. That's the thing we just did. If you have 2 exponents with the same base, you use all the powers. Same thing with natural log and log. You can cancel them out. If you only have one log, if you only have a natural log, then you want to take the e of both sides. That would cancel it out. If you have an e, then you're going to take the natural log of both sides. That would cancel these out. And if you have a log by itself, you take the base of both sides. That cancels those out. That's the general idea. If you can make them match, like you can make the 2 sides match, then you just equate the powers or equate the insides. If you only have a natural log, use e to cancel it out. If you only have an e, use natural log to cancel it out. If you have a log, you use the base to cancel it out. So that's the general gist. Let's do some examples. Ex equals 72. So we're going to take the natural log of both sides. Like that. These cancel out. X equals natural log of 72. Over here, first thing, you want to get rid of that 3. We can't get rid of the 2 yet, so get rid of the 3. Let's divide both sides by 3. 2 to the x equals, let's see, 3 goes in there 14 times. This one we haven't seen yet. These, I cannot make these the same base. What we do here, so we're going to take the natural log or log of both sides. So I'm going to take the natural log of both sides. And I get natural log of 2x equals natural log of 14. Anytime you cannot get the bases to match, you want to take the log or natural log of both sides. I'm going to take natural log because the letters are a little shorter. There's only 2 of them instead of 3. And then we get to this step, and then we have to move this power to the front. X equals natural log of 2, which equals natural log of 14. And now we just got to get the x by itself. We'll divide both sides by natural log of 2. And that's it. You can't do anything else. You got natural log of 14 over natural log of 2. Just to show you another way of doing it, we had 2 to the x equals 14. Another way you could do it is you take the log base 2 to both sides. So what happens there is 2 and 2 cancel out, you just get x. And you get x equals log base 2 of 14. And those are actually the same answer. They look different. This is log base 2 of 14, that's natural log of 14 over natural log of 2. But don't forget, change the base. You could split this to be natural log of 14 over natural log of 2. Or any other base. The exact same way. Any way you prefer to do it, if you're a little more pro, you could go, wait, it's a base 2, take the log base 2 both sides to solve, or you just take natural log both sides. You always want to take natural log if it's an e, because then it cancels out right away. So it's this one. Let's solve it. There's an e problem. We got to get the e by itself. Let's get rid of that 3 first. So you get 4e to the 2x equals 5. Then we're going to divide by 4. You get e to the 2x equals 5 over 4. The only way to get rid of e is you take the natural log of both sides. You take the natural log of both sides. These cancel out. I'm left with 2x is equal to the natural log of 5/4. And then we're going to solve for x. We're just going to divide both sides by 2. So I get x equals natural log of 5/4 over 2. Or if you want to be a little pro, you can write this a little nicer. You could say 1/2 natural log of 5/4. Or if you really want to be even more pro, we can bring the 1/2 to the front and make this natural log of square root of 5/4. All these are acceptable. I don't care which one you give me. They're all the same. This is like the nicest answer, but it's all good. Over here, we're going to solve for exponents. The same idea, except for I can just use a natural log to cancel out the e. This is the power. So we're going to do the same thing. Let's get this guy by itself. We're going to add 4. I get 2 times 3, 2t minus 5 equals 15. Let's divide by that 2. And we already have fractions. 15 over 2. We're pro. We can take the natural log both sides if we want. But let's take the log base 3 both sides, so get rid of that 3, since we know what that does now. Log base 3, these cancel. You get 2t minus 5 equals log base 3 of 15 over 2. And then all we're going to do is add 5 and divide by 2. This is just a number. If you put this in your calculator, you get a decimal, you just add 5 and divide by 2. Or you could leave it the way it is and just add 5 and divide by 2. I get 2t equals log base 3 of 15 over 2 plus 5, and then divide everything by 2. Like that. This one is an e problem, but there's 2 e's. So you cannot just try to get e by itself. This is a quadratic. If you look at it, if we pretend like e x equals w, what's going on here is this is the same thing as saying w squared, because e to the 2x is the same thing as e to the x squared. When you multiply powers, when you take like a power to power, you multiply. These are exactly the same thing. This is just like a w squared minus 3w plus 2 equals 0. If I just gave you that as a problem, you'd be like, I just factor it. Big X, 2, negative 3, this would be negative 2 and negative 1 over 1 over 1. You get w minus 2, w minus 1 equals 0. That's what we're going to do here. Just going to factor this. And I see you can factor like this and just plug your e back in. These are just e to the x's. So you could either factor straight from here all the way down there, or you could do something like this. I'll call it substitution. You substitute ex with a variable, rewrite it so it's a little easier for you to see. And then you just factor that like normal. Then you plug it back in. I substituted it and I plugged it back in. And now we just split and solve each one separately. E to the x minus 2 equals 0. And e to the x minus 1 equals 0. E to the x equals 2. Take the natural log of both sides. X equals natural log of 2. E to the x equals 1 on this side. Take the natural log of both sides. X equals natural log of 1. The natural log of 1 is always 0. E to what power gets me 1? 0. That's how you do that. That's a harder problem with the e to the x's, but it's the same idea. Either factor it or substitute it and then factor it. Now we're going to solve log equations. The thing I said earlier still applies. The easiest way to solve a log equation is you take the base to both sides. Base to both sides. Actually, there's a step before that, which is condense. You got to make sure there's only 1 log on each side. Or 1 log on a side. You can't have 2 logs on the same side, basically. So you can see here, natural log of x equals 3. The base of a natural log is e, so you take the e to both sides, so you get your answer. That's what I'm going to do here. Oh, natural log of 3x equals 2. We're just going to take the e to get rid of it. Remember, you take the e as a power. It's a little funky. E to the natural log of 3x equals e squared. That cancels. You get 3x equals e squared. You get this. Divide by 3. Divide by 3. X equals e squared over 3. The next one's a log one. Same idea. Like technically these are equal, you just cancel them out. But why that works is because you take the base of 3 to both sides. These cancel, you get 5x minus 1 equals x plus 7. Now it's just a simple algebra 1 problem. Minus x from both sides, add 1 to both sides. 4x equals 8, divide by 4, you get x equals 2. Now there's a thing here I'm gonna mention. When you do logs, you're supposed to check the domain. The inside has to be greater than or equal to 0. Like you can't plug in a negative log. When you get a log answer, you're supposed to check it. Make sure that you don't get a negative number when you get in here. 2 plus 7 is 9, that's okay. 2 times 5 is 10. 10 minus 1 is 9. It's okay. This is all good. Solving for a log equation is this one. Well, we're just going to solve for natural log. Let's get that by itself. So minus 5, 2 natural log of x equals negative 1. Divide by 2. Natural log of x equals negative 1/2. Then we're going to take the e of both sides, get rid of the natural log. You get x equals e to the negative 1/2. I know I just said you can't have a negative answer. This is not a negative answer. It's just a positive. This is just a really small number. This is e to the negative 1/2 power. You're going to take the square root of e and then flip it. So it's still positive. Next one. So we're going to solve for the log. Let's divide both sides by 2. I get log base 5 of 3x equals 2. Now remember, the way you get rid of a log, there's only one log here. You take the base of both sides. Take that 5, take it here, take it here. These cancel. 3x equals 5 squared, also known as 25. Divide by 3. X equals 25 over 3. This is mentioning what I talked about earlier. Since logs have a very specific domain, which is if you have a basic log equation or natural log equation, does not matter. The domain at x has to be greater than 0. But you cannot plug in negative numbers into a log. Like here, you should always check it technically. When I solve this, you're going to see it's not going to work out totally. In this case, how do I solve this one? Remember my first rule. I can't just take the e to both. The most common mistake is people just do this. And that's wrong. It only works when there's only one natural log on each side. First, I got to combine these. Call that condensing. Plus means multiply. So this is sending us a natural log of x minus 2 times 2x minus 3 equals, even on this side, we're going to try to move this. You can't take the e yet because that 2's in the way. Let's move this up here. Natural log of x squared. And now there's only a log on each side. I can take the e of both sides. These cancel out. And I get x minus 2 times 2x minus 3 equals x squared. So we have a quadratic we got to solve. First, let's distribute this. X squared minus 3x minus 4x plus 6 equals x squared. Now, we want to set equal to 0. Anytime you solve a quadratic, you want one side to be 0. Let's subtract the x squared from both sides. And I get x squared minus 7x. Those two we put together, plus 6 equals 0. This I could factor. 6, negative 7, that would be negative 1 and negative 6. So you get x minus 6, x minus 1 equals 0. Split it, x equals 6, and x equals 1. I kind of skipped the x minus 6 equals 0, x minus 1 equals 0. But you get 6 and 1 is my answers. But let's check our answers. Remember, we cannot get a negative when I have a log. If I plug x into here, I get 6 minus 2 is 4. Good. Into here, 12 minus 3 is 9. All good. We plug in 1. 1 minus 2 is a negative 1. 1 does not work. When you plug it into this guy, you get 1 minus 2, which gets you natural log of negative 1. That's a non-real result. My answer is only x equals 6. Okay, applications. Let's say you have deposited $500 into an account that pays 6.7% interest, compounded continuously. How long will it take for you to double your money? This is compounded continuously, so you gotta remember our formula, APERT. Let's plug everything in. We deposit $500, that's our A. We have our rate, 0.0675. Let's plug in what we have. 500, e to the 0.0675 to the t. I want to double my money. So what's doubling my money? Well, double 500 is 1,000. Like that. So all we have to do here is we have to solve for t. We're going to get the e by itself. If we want to get this guy by itself, so we can solve for t. Let's get rid of that 500. Divide both sides by 500. That cancels out. 1,000 divided by 500 is 2. Hey, double money. 0.0675 t. We get to here, and then the way you always solve an exponential, if you can't get the bases to match, you take either the log or natural log both sides. In this case, we'll take the natural log of both sides, because that e cancels out right away. You get natural log of 2 is equal to 0.67 t. And now all we have to do is divide by 0.067. These cancel out, and you get t equals, well, I need a calculator. Let me get that. So we have natural log of 2, natural log is here, close the parenthesis, divided by 0.067. It's going to take us about 10.3 years. It's about 11 years, I guess. How long would it take for money to double? So 10 years it wouldn't have doubled. How long would it take it to double? I could say 10.3 years. You can't say 10 years because it hasn't doubled yet, so 11 years also works. I'll accept either of these answers. Average salary for public school teachers, our last problem. From 1985 to 2007, the average salary for public school teachers in $1,000 is modeled by this equation. We have this equation here, it's a natural log, where t represents 1985. During which school year did the average salary for public school teachers reach $45,000? It is in thousands of dollars, so we're going to plug 45 in. We got to watch that. It's in thousands of dollars. 45 equals negative 2.983 plus 15.206 natural log of t. Our whole goal is to get the natural log by itself. And then we're going to take the e of both sides. First, let's get rid of this. Plus 0.2983 plus 2983. I get 47 plus 0.983. You could definitely use a calculator on this, like that. And then we're going to divide both sides by 15.206. We get natural log of t equals 47.983 divided by 15.206. And I get 3.155. Here I'm just going to write 3.155. On the calculator, I'm going to leave it all in there. All we have to do next is get rid of the natural log, so we're going to take the e of both sides. These cancel out and I get t equals. On my calculator, I'm just going to leave it and put second e, and then I'm just going to stop there and select it. Get my answer, 23.46. It's to take about 24 years. 23, you haven't made 45K yet, so 24 years. If we're going from 1980, it says which year. This is about 24. 1980 is where we start, so we're going to add 24 to that, and we're going to get 2004. So in the year 2004. And that's a lesson.